What I want to do today for the next 25 minutes or so is to send one very clear message, and that is the need for you to understand energy as an entire system and also appreciate the value of partnerships. To illustrate the second point, let me do a quick poll. How many of you are from the Dorr School of Sustainability? Okay. School of Engineering, Humanities and Sciences, GSB, and Policy Institutes? Okay. Oh. So it was a pretty equal distribution, which means that to address, mitigate, and solve the energy crisis, enable the energy transition, it really requires a lot of people to come together, work together. And as you pursue your graduate degrees, you will be focused on your specific discipline. Why are we here? And I'll tell you a little bit about Precore Institute in a second. The reason we're here today is to recognize the need for gluing. We need to glue all of these disciplines together. As you go deep, you also need to maintain the breadth at the same time. And that can be done by talking to your colleagues here, by talking to us. And that's really what this event is for you to understand and appreciate how many skill sets are needed for you to be prepared to address the energy transition. So let me tell you a little bit about myself. So 20 years ago, I was in your shoes, starting my PhD. And to give you a sense of what has changed or what hasn't changed, that was the year 2005 in which the Kyoto Protocol was enacted, came into effect. I think largely history has it that the Kyoto Protocol wasn't that successful. However, it started the conversation. At that time, Tesla was about 1 year old. Nobody knew Tesla. The cost of solar was about 50 cents a kilowatt hour. Anyone know the cost today? About 3 cents on average. Cost of battery was about $2,000 a kilowatt hour at the battery pack level. Someone on the cost today? A little bit over $100 a kilowatt hour. I only knew of one tech startup in the energy area, and that was Bloom Energy. They're still in business today, commercializing fuel cell technologies. Today, the landscape is vastly different. We're now spending, as of last year, about $1.3 trillion on the energy transition. When I started, the word energy transition wasn't coined. So that tells you how far we have come in the past 20 years. With that said, we are just scratching the surface, and I'll tell you some concerning statistics as well going forward, especially on the need to accelerate. So let's get into the Precore Institute, why we are here to act as the glue for the entire Stanford University, not only inside, but also with all of the amazing external partners that we have. So our vision can be simply stated as sustainable, affordable, and secure energy for all. Achieving all of those attributes at the same time is extraordinarily challenging. And I believe all of you are here today because you're excited to contribute to a vision. You'll do your part on it, but it's very important to see the entire picture, which is what this whole week is about. To get to this vision, our mission is to accelerate and architect the energy transition through a system-first and a partnership-based innovations. I will get into details in a bit. The Institute has 3 pillars: Pioneer, Integrate, and Propel. This is roughly our innovation, analysis, and education pillars. Bianca and others you have met today are in the Propel pillar, and our task here is simple: to propel you as you pursue your education in specific departments and schools, and to think about how to link everything together so you have a good appreciation to the complexity that the energy system is. What I will do now is to walk you through 5 take-home messages. The first one is the time scale for action. Let me give you some numbers that really concern me. 25 years, 1% in 50 years, and 2150. I'll tell you what these mean in a second. Quarter of a century is roughly what we have in terms of our remaining carbon budget. So if we continue businesses as usual today and we don't change how we emit greenhouse gases, we roughly have about a quarter century before we breach the 2 degrees C temperature rise over pre-industrial levels. So that gives you a sense of the timeline we're dealing with here, quarter century. And you might be thinking, well, we are pretty good at deploying solutions. So let's go ahead and look back. This is a bar chart showing the time it took to develop a technology from scratch. Okay, that's the dark blue part, to initial market introduction. And then the light blue shows the first 1% deployment. There's some really interesting items here. There's wind, EV, solar, and even green steel. It might surprise you, for example, for direct reduced iron, say, for example, using hydrogen rather than coal, we've invented this technology more than 100 years ago. If you look at the average time of research and development required, and that's some of the things we do here at Stanford, it's on the order about 20 to 30 years. And then it takes another 10 years or so to get that first 1%. And then it takes usually another 15 to 20 years to penetrate to the 75% mark. The reason why these times are so long is things related to the energy transition are often very infrastructure heavy and therefore very capital heavy. And I'll give you more insights there. So roughly, it will take us, depending on the technology, about 40 to 50 years to get to that first 1%. So you can already see there is a 2 to 3x mismatch in time scale. On one hand, it's not terrible. It's not one order of magnitude. On the other hand, it is coming. 2150, this is a bit of an ominous number. This is roughly when my grandchildren will live until. So they will see the full effect of the decisions that we make in the next 25 years. Okay, so keep these numbers in mind. The second thing I want to talk about is the scale of the energy transition. To put this in perspective, to establish a 24/7 clean electricity system, so this is using technologies we have today, solar, wind, batteries, and others. It will take approximately $70 trillion. For comparison, the world GDP is about $100 trillion. And that's just for the electricity sector. This doesn't yet include mobility, heavy industry, buildings. Okay, so this gives you a sense of how enormous the financial task is here. Anyone know about how long it would take, well, how much total money it would take for the entire energy transition? About $500 trillion, isn't it? Okay. Scaling is not something that is foreign to us, as I mentioned. We have done it many times before. Steam engine, internal combustion engine, the electricity system, TVs, refrigerators, phones, software, and so forth. The reason why the energy transition is particularly challenging is because the things we're trying to introduce, the products we're selling, are commodities. Think electricity, heat, steel, cement, miles transported. There is no better miles transported versus lesser miles transported. It's miles transported. It's a commodity. And because it's a commodity, there are strong incumbents in the system today. So for the energy transition to work, you have to recognize these two things. Therefore, the challenge becomes, how do you finance the learning curve? So I gave those incredible learning curve numbers for solar and batteries, how it really came down. But it took hundreds of billions of subsidies, investments to bring the cost down. And it's not a simple task. And replicating that to even more commoditized markets, such as steel and cement, will be more difficult. The final point I want to make on scale is also disruption versus scalability. This will come perhaps as a provocative statement to some of you. How many of you came in here thinking, I'm here to really disrupt my field? New thinking, new technology, new approaches. Raise your hand. Are you a disruptor? It's not important. One of the challenges of disruption is also you have to reinvent your infrastructure. You have to build new plants, maybe new capital-intensive investments. Often when things are too disruptive, it's hard to scale. And the disruption is not only in terms of the technology itself, it could also be manufacturability. It could also be market design. One of the really great example of a drop-in success, and that you saw that on the first bar chart in the previous slide, are LED lights. It's a true drop-in. You take the light off, you put the light on. Because it utilized existing markets, it was easy to deploy. The timeline for LED was much faster. But this will continue to be something we have to wrestle with. I'm very pleased to tell you, and this is the plug for myself and my co-instructors, that we're offering a course on scaling sustainable solutions. All of you take out your phones. I told my colleagues I will be checking the enrollment before and after this hour, so please make it look good. Oh, good, thank you very much. At least we have one. Sustain 170, 370 in the Door School of Sustainability will look at 3 examples of scaling in the past. Solar, which really requires no introduction. Phasing out CFC refrigerants, the Montreal Protocol, and nuclear. All of them have a purpose. Solar is a really good example of geopolitical constraints on the energy transition, the role of China. For example, we're going to have outstanding scholars and practitioners talk about that. CFC phasing out is a really great example because it started with a scientific understanding and discovery of the ozone depletion, and it very quickly led to policy in which industry have about half of the solution in place. And we're super excited to welcome Chad Holliday, who was at the front line of DuPont when this happened. And he also later served as the chairman of Bank of America and Shell, so he will be our lead speaker. Finally, nuclear. This is one of the very few technologies, at least in the United States, the cost is rising, not decreasing. And we will have our experts, such as Nobel laureate Steve Chueh, talk about why this is the case. So I encourage you to think about coming to this course. It's an advanced seminar course. It's a series of dialogues with those on the front line to share their experience on scaling. So we may think about, where do we go from here? How do we do things differently? The third point I would like to make is the many kinds of innovations required. As a material scientist, I often think, well, innovation means new materials. But it's a lot more than that. When it comes to the energy transition, we need innovations across the board, not only in the technology from the lab, but also in terms of the process, the manufacturing, the capital costs required. But beyond the technology and the product side, also the policy mechanisms. market design. I'm so glad to see so many disciplines represented in this room because the combination of all of your interests and expertise will be required. So do not underestimate how innovations will stack. This is a very important part. You will probably be looking at a very small cross-section of innovation in your research, in your education. However, please spend those extra time to zoom out and see how it intersects with other fields. I think that your colleagues here are your resources. 2 more points, and I'll stop talking. Systems lens. At the end, the energy transition is a transition of the energy as a system. A lot of things that we work on individually, myself included, are components of a component of a component. For example, I work on energy storage technologies. Batteries is a component in a battery pack. That's a component in a car. A car is a component in the mobility system, which has chargers and the electricity grid and autonomy. So we need to begin to think about looking at the problem at the systems level, even though the things we work on are super small, granular, detailed, maybe on the levels of atoms as I do. Having that systems view keep you grounded on how to ensure we make impact at the end of the day. At the Door School, we're very fond of saying working backward from the solution. And that means appreciating the solution at the system scale. And I'll offer this plot. The energy transition, as my colleague Holmes reminded me, is not one transition. It's many transitions. In fact, it's many transitions across multiple scales. Of course, we will transform our economies, but we also have to transform each sectors. I just listed a few that are important to us at the Institute: electricity, mobility, heavy industry, buildings. We're also transforming technologies, and here you have a bunch. And even beyond that, we have to think about supply chain. Where do the materials come from? Many of us will be working on maybe one block here. Some of us will also be working not vertically, but horizontally. For example, on the important topic of equity across the board. And that's how we can begin to think about the energy transition as a whole system. Some of you are studying the energy transition as a system analyst, but I think most of you likely will be zooming in. So please keep this overall picture in mind to see how your solutions will interact with the system as a whole. I challenge all of you to think about, especially if you choose the topic of your research, the topic of your specialization. Is it the bottleneck in the system? Will it make a difference if it succeeds? I think based on the timeline challenge I mentioned, the problem selection is extremely critical. Finally, I want to end on the note of partnerships. All of you are partners. You're also partnering with us at the Institute. Our Institute has the formidable challenge of linking all of you together, acting as the glue, but we also have to link our external partners. Why are partnerships so important? When I were in your shoes 20 years ago, there weren't a lot of actors outside of academia looking at the energy transition. But now there are tens of thousands of actors, whether they are government, financial, industry, and everyone in between. And the way we look at this is, what value can our partners offer to us? What value can we offer to them? So in terms of policy, our partners in government, whether it's on the legislative aspect or the executive aspect, they have a lot of experience in formulating the policy and also running them. There is a lot of experience that we can benefit from. Of course, there's always money, but they also bring about understanding of real world challenges because they are practitioners. Compared to 20 years ago, there is a huge amount of data on deployment, granular all the way to system. And our job is to bring all of these elements of partnership into Stanford to empower you, but also then to work with all of you and those interested through other programs at Stanford, such as the Sustainability Accelerator, bring our learnings out so it could become a very fast and efficient learning cycle to enable the energy transition. So I've said a lot. I hope these 5 points are meaningful to you and why this is a very exciting venue to talk about it. Over the next 5 days, please ask hard questions. I would encourage you to use these 5 points as guiding principles and poke our speakers, our experts, our faculty, our staff colleagues to ask them, how do we realize these goals? Let me pause briefly here to answer a few questions, and then we will get started with the rest of the program.
Thanks. My name's Dylan.
Dylan. Hello, Dylan. You're from?
I'm from Utah.
Utah, okay.
Is that what you're asking for?
And where did you do your previous training?
At Brigham Young University.
All right, welcome.
You mentioned a good thing we can keep in mind is to identify bottlenecks as problems. What's a good way to go about identifying bottlenecks?
This is a $1 trillion question. Part of the challenge lies that we don't have very good predictive models of how particular interventions or innovations at a small scale would translate. So this is part of the effort across Stanford to develop these models. Then we can take sort of small perturbations in particular areas and see how it propagates at the end. Because at the end, we want to deploy these solutions. So I would say this is an on-the-met challenge. I think some of you will be working on this. And if you're still open in your area of research, I think this is a very attractive option. But the short answer is we don't quite have the tools, but we are actively working on it.
And I'm Sam, I'm from Boston. You had a slide earlier about how it would take 70 trillion to do like clean energy, just
electricity.
Does that cost calculate like the amount of emissions used for that transition and how to negate those, or is it just like the transition itself?
It does. This was a calculation performed by my colleague, Mark Jacobson, and I'm happy to share the original paper on this topic. And these numbers are constantly changing. This is part of the challenge, but I think at the end of the day, it is a very, very large number. Much of the cost is going towards mitigation as well. But for this number, this is just for transforming the electricity system. Was that a question in the back? Yes.
Jason from the Bay Area. My question is, so with that figure that was on the slide, $70 trillion, how much of that for our transition will require new technologies, and how much will that require business model innovation? And like, where do you think our priorities as researchers, as like business leaders should focus on?
This is another $1 trillion question, so everybody have the right mindset here. There's not a straightforward answer to that. I think, as I mentioned, the innovation part, it's not just the new technologies, it could also be new manufacturing or new policy mechanisms. I would say the number that Mark calculated was based on solutions we have today. But as some of you know, as we approach a higher degree of penetration for renewable electricity, the job gets harder. So it's a little bit difficult to forecast whether or not we have all the technology we have today. To give you a sense, we've only built about 1.5% of the batteries needed for the energy transition across mobility and the electricity grid sectors, which means a vast majority of the factories have not been built. So I think the short answer there is, yes, innovation will be there. The question is, how big will the innovation be? Will it be the super disruptive kind or the incremental kind? My guess is you need a little bit of both, because you want to keep the deployment going, but you also want to prepare for 20, 30 years down the road. As I mentioned, it takes about 50 years based on today's pace to bring a new concept from lab to that first 1%. I think if we do our job right for the next few decades, we can shrink that substantially. So that opens up the possibility for introducing innovation and scale at the same time. It hasn't been done, but I think this will be the place to do it. Maybe one last question. The back over there in the red, yes.
So I'm not still, I'm becoming a PhD student. So like actually building off of that viewpoint. So you shared the statistic about having only a quarter of a century before we have to mitigate like for the timeline for the 2 degrees rise in global temperature itself. And so doesn't that also kind of imply that we have to accelerate the that we have already over like building up more of these long-term strategies? And how will we actually balance that thing right without that?
Yeah.
The impending deadline.
What a terrific question. Yet another $1 trillion question. I think this is the point I was making earlier, disrupt versus scale. So as we think about meeting this short timeline, by the way, that timeline is just a metric because that assumes we don't do anything differently, and we are doing things very differently. So that timeline is in practice longer. But if you think about things that we can do today, we are manufacturing, we are providing, we're scaling solutions we have today. So there has to be the right balance. And some people might say, we at Stanford, should focus on just the pure cutting edge innovations. I disagree. I think we can also contribute to improving the processes we have, not only through the tech lens, but also the manufacturability lens, through the policy lens. There's so many things we can do. So I hope that inspired you to think about, it's a little bit of everything. And I think that goes back to my initial remark. We really need all of the above. That's why all of you are here. So please keep this overarching broad view of the energy transition in your mind as you pursue your training here at Stanford. So we are now at time. We are now very privileged to have Professor Arun Majumdar join us. Arun is our Dean of the School of Sustainability. Like many of us, he is also part of the School of Engineering and other parts with the Precourt Institute, with Hoover Institution. And Arun, if I may use 2 words to describe you, I've been thinking about this all morning, is dynamic range. When you have a chat with Arun,
Very engineering term.
oh no, I will give the broader version too. You can have a chat with Arun, if I'm a material scientist, from atoms to the planet. If you are on the business side, you can talk him from cents to trillions. Time scale, you can go from picoseconds to centuries.
You missed femtosecond.
Femtosecond. Arun is a true scholar and a practitioner at the same time. This doesn't come together all that often. Having experience not only teaching, training students at Berkeley, at Stanford, having founded RPE at the Department of Energy and served critical roles there, spent time in industry with Google and dabbled in entrepreneurship, and now here leading the first school in Stanford over 70 years. So I encourage you to also poke Arun about his dynamic range, maybe push it, but you can have conversations of all kinds with Arun. So without further delay, Arun.
Thank you. Hi, how are you guys doing? Good. How many people are here first time in the United States? Raise your hands. Welcome to the United States of America. How many first time at Stanford campus? Welcome to Stanford. How many in California first time? That's great. I think, I really hope you find Stanford as a welcoming, it's a sense of, I hope you get a sense of belonging out here. And hope you leave, the beauty about graduate students are they come and they leave and then they shine. And I really hope you bring the shining light on this world, on all the challenges and frankly, the opportunities that you just heard. I would rather have a conversation than give a talk. You already saw some slides, but I just want to give you a little background of the Door School. This is a giant experiment that we've done. How many from Stanford? Show of hands. 1, 2, 3. Yeah. This is the first school Stanford has launched in 75 years. I don't think anyone out here was around the last school, so there is no playbook. We're just making it up. And the reason we launched a school is that it is arguably the defining challenge and the opportunity of this century. And the paradigm of the 20th century growth of sustainable development in general, economic growth, GDP per capita, and all has consequences. And so we have to address that with knowledge, with education, with innovation. And that's part of the reason we launched the school. And it's, if you look at sustainability, it's not just an energy issue, it's an energy. What happens to energy affects water. You know that, loud and clear in California. What happens in water affects food and agriculture. What happens in food and agriculture affects biodiversity. That affects ecology. That affects public health. And climate change aggravates all of them. And so as a campus, we wanted to take as holistic an approach to this so that we don't fall in the trap of unintended consequences, which is frankly, we're living in the unintended consequences of the 20th century. And so that's part of the reason we said that this is a major theme. It came grassroots from the faculty, from the students, from our alums, from our community, that this is a big deal. And it is, sustainability is one of those areas, all the things that I just talked about, energy, food, water, et cetera. It doesn't fit neatly into how universities are organized. It's not just an engineering issue. It is also a business issue. It's a law issue, right? It's a health issue as well. So, it really needs a whole campus effort. And so when we designed the school, we had that in mind. Yes, we will define a school because in a school it'll have departments, because that's where you hire faculty, you admit students, you offer degrees, we develop curricula, et cetera. But the education that we develop is not just for the students in our school, it's for all the students. The research enterprise, the Precourt Institute, it's not just part of the door school to serve the door school, it's there to serve everyone. And the same with the Woods Institute, we're going to have the director of Woods Institute come in. We're going to launch a third institute, Sustainable Society Institute. And that is, it's really an all-campus effort. The accelerator that you heard about, which is really to think about scale from the beginning and get it launched and get solutions launched, whether it's policy, solution, technology, it's an all-campus effort. We have very close partnership with all the other schools. In fact, I think the accelerator has very close partnership with GSB. How many GSB students are here? By the way, just so you know, this is the 15th time we're holding it. GSB students have been the loudest. I hope you guys keep up the tradition. So this is, again, we are 2 years in, we're starting the third year, and we are taking that all-campus approach in this, connecting the dots. And some of the educational things that the Precourt Institute has done at best is to look at things that are all campus. There is something called, first of all, the scaling class. It's really connecting the dots and really looking at scaling as holistically as possible. And we have checked with other academic institutions around this country. No one has a course on scaling. So what we're going to do is to not only develop that curriculum out here, we're going to share it with other academic institutions because, looks like people need it, that education. We are, there's a course on Stanford Climate Ventures. There's a partnership with GSB on something called ecopreneurship. Okay. I hope you all leverage those. There's a center called the Tomcat Center after Tom Steyer and Kat Taylor. And that is now part of the accelerator. And that is for really putting resources into students' hands if they want to launch something. Before a startup, when you launch a startup, you could be here taking a course in Stanford Climate Ventures, taking some classes in GSV, et cetera. And you get a little bit of resources to develop an idea before you get it launched. So I really hope you take advantage of that. What we have seen in the past in this boot camp that we create, this is really, you're part of a boot camp now, is really an opportunity to get to know each other, get to know what's going on campus, who's doing what, create a network, and hope this network is useful to you, not only for partnerships that you do out here, but after you leave, that you still remain in touch. And the network is the most powerful thing you can ever do. So that's what this school is about. We are super excited to have you here. Let's have a Q&A. Let's have a conversation with you.
My name is Linda from GSB. Since you took office a few years ago, spoke about just how special this Dover School is. Let's take a look at resources from the entire campus. I'm curious from your personal perspective, having taken many roles in the past, what has been pleasantly surprising about this role in the past couple of years, and what has been disappointing?
Well, the pleasantly surprising part, the two things, the amount of interest among the students is phenomenal. And this is not just graduate students like you all, but the undergraduates as well. And so we've had the data on how much the number of students in our classes have gone up. So that has been very positive. The other thing I would say, the positive part is the amount of interest from the outside. Just to give you a data point, we had not planned for it as well. In the first year is what, 50 weeks, 2 weeks you take for vacation, right? 50 weeks, we had 55 heads of state or deputy heads of state or CEOs or C-level execs come and want to find out what's going on. And that was overwhelming, but I would rather have a problem like that than otherwise. Okay, so that's been very, very positive. What's been disappointing, I would say it's more of, look, Stanford has been around for 140 something years, right? To take an academic model, not just at Stanford, any other university, and gear it towards sustainability, which is an all-campus effort, takes some time because you are bringing people from different parts of campus together. Just to give you an idea, we have a total headcount about 140 faculty already here. We're going to hire 60 more faculty, but 140 faculty are already here. Half of them have joint appointments. Okay? And we have joint appointments with every other school. This is the first time this has happened at Stanford. So now you got people from social sciences, you have people we have launched a department of environmental social sciences because we think people are important in this. Social science is important, humanities is important. We've launched a department of oceans by bringing in faculty from the biology department in humanities and science school, right? And other people from civil environmental engineering. Civil environmental engineering is a joint department. Okay, this is the first time an existing department has become joint and is the founding department for two schools. It was the first department in the School of Engineering, and it also was one of the founders of the Dover School. So there are many, many new things that are happening. Trying to get all of that together amongst a common goal takes time, and that's what's going on right now. Yes, ma'am.
What are some of the innovations, whether they're like business policy or tech, that are being incubated right now that you're most excited?
Oh, you need to hear about from the accelerator. There are lots of things going on out there.
That stands out that.
I'm sorry?
Is there one or two that stands out that you're really excited about?
I have my biases, just like my children. I should not be talking about one of them. But there are some really cool things going on. I mean, there's a terrific, there are some projects that are going on measuring, just greenhouse gases with the precision that is needed. And we hope to get it on a planetary scale, right? And so that, by the way, we are woefully inadequate in measuring all the necessary parameters for climate change on a global scale. You know how many satellites are there measuring CO2? Anyone has any idea? I actually wrote an op-ed on this because it was so shocking. There are 2 satellites, OCO2 and OCO3 from NASA, that are measuring 1% of the Earth's surface per month. And they are both beyond their life expectancy, and we don't have a plan for replacement. That's where we are. And we said, we can't let this happen. I mean, if this is such a big challenge. So all the estimates that you see, the US is reducing its greenhouse gas emissions, and China is emitting so much. These are all estimates. No one has actually gone and measured satellite level. So so that's a really interesting projects. Okay, I'll show my bias now. We have a couple of projects on converting agricultural waste to biochar. We think that this is scalable, potentially. And just so you know, one of the the basic idea about the accelerator is to think about scale from the beginning. And just look at carbon dioxide for a minute. It's a gigaton scale problem. And we got to think about gigaton. So you ask first of all, you throw these numbers in gigaton units without really thinking. So let me ask, this is the first quiz you're going to get from me. If you add up the weight of all 8 billion human beings on Earth, what is the weight in gigatons? Anyone has an estimate? I'll give you 3 seconds. 3, 2,
1/10,000.
1 what?
1/10,000.
1/10,000 of gigaton?
Sure.
Not quite close, but it's half a gigaton. It's half a gigaton, and we're talking about tens of gigatons, right? How many industries are there which are already at the gigaton scale? You can count them on your fingers. It's oil, gas, steel, cement, coal, agriculture, and maybe water. That's about it. So the way we're thinking about this, and not just the many people, is that can we hack some of these industries to solve the gigaton scale problem? And agriculture is one of those that absorbs CO2 from the atmosphere, right? So biochar being one of the solutions out there. So, but there are many. I don't want to bias you in this. There are many such projects going on, both at the Precourt Institutes, the Woods Institute, and the Accelerator, in trying to get these solutions out. Yeah.
So Silicon Valley's been the center of like technology and innovation for decades now. Is there a geographical area that's kind of an outlier for sustainable innovation? Is it the Bay Area? Do you see the Bay Area being that? Or do you think it's going to be more of like a virtual team up of just different, disciplines, because it's such an interdisciplinary area. So I'm just curious your thoughts about that.
It's a great question. So yes, we are blessed to be in this ecosystem, innovation, yes, all that. This is a global issue. And it is very important for us to take a global view. Not only because of the conditions, of the environmental conditions that are there. What happens in the global south and the tropical regions on heat waves and humidity is very different than what you see out here. We complain about some of the heat waves, but it's not 50 degrees Celsius, right? So I think it is very important for us to understand and keep the network and connections with our partners around the world. So in my first summer, after 1 year, I spent about a month in Asia. Because I think, first of all, there are a lot of people there, and the conditions for whether it's climate or food or water, et cetera, there are some real stresses going on out there. So it's very important for us to understand and partner. And to be able to co-develop some of these solutions, first of all, understand what's going on, for us to learn, for them to teach us what's going on, and then hopefully use our collective knowledge to co-develop some things. So that's how we look at it. But of course, we're blessed to be here in this innovation ecosystem. And frankly, beyond just Stanford campus, there's a huge amount of interest in this industry and industries out here in the field of sustainability. Yeah, I'm gonna go there. Yes.
You're talking a lot about like bridging disciplinary perspective gaps for energy transition. What gaps have been the hardest to bridge, and also like going forward, which ones do you think are going to be most difficult and also most important?
I think the understanding of scale. I don't think we pay enough emphasis in academic institutions, right? People in the industry, people in the government understand scale and what a policy, the implications of a policy on an economy-wide or a statewide, right? Or how do you get to something economy-wide in a technology? Scaling in tech industry and scaling in this is very different. The capital requirements are totally different. The return on margins of return is very different. So putting together the curriculum, which is why we decided that I think it's important to develop some curriculum where we bring people from the outside, bring people from across campus and focus on this is going to be very important. So I think that's one of the gaps. The other gaps are, it's in academic institutions, we have interdisciplinary institutes like the Pre-Court. But there are a lot of faculty, what we're finding is they have developed their expertise in a certain domain. And they had not thought about connecting it to issues related to climate and sustainability or earth sciences, right? Now they're finding is that, oh my God, there's a school out here that is dedicated to looking at that. Maybe my skill set could be important, my knowledge could be important out there. And there's a lot of those connecting of the dots going on, which is fantastic. But there was a gap that is being filled right now. Last question. Okay, there.
Thank you for having us here. My name is Arnav, and I'm coming in GSP school. My question is that not all energy transitions are equal, right? And as the school is thinking about people, time, and money, how do you think of allocating each of them to different problems? And is there a framework that we should adopt?
I mean, you're asking whether I should be allocating?
How does the school therefore think about the different energy transitions given all of them?
It's a very interesting question. So every country is starting from a different initial condition. And there are different boundary conditions, right? So one of the things that we are starting right now, and we're doing this for a little bit, but we're formalizing. So we have a meeting called the COP meetings. How many of you have heard of COP? So we just finished COP 28 in Dubai. The next one is in Baku, COP 29. COP 30 is going to be in Brazil in next November 2025. And that's the 10th anniversary of the Paris Agreement. And all countries are supposed to provide a framework, a policy framework of how, and the transition pathways to make their own commitments that they've made, right? And so we are putting together an effort with Chris is right there, Chris Field, the director of the Woods Institute, Chris and Sally Benson, who's the former director of the Pre-Court Institute. They're going to lead an effort on working with a few countries, one in Asia, one in Africa, one in South America, and what else? This. Two in Asia, that's right, Indonesia and India, South Africa and Brazil. And the idea is to work with them, evaluate their transition plans, see if we could add anything to it, and maybe help, perhaps bring innovation into their economic discussion to see whether they can go cheaper or faster. So that's something that we are, in the process of getting launched. I think I'm out of time. But it's a pleasure to have you. Really, really.